Right. So who am I? I'm Nathan. I'm a low-level developer at Rookout. I consider myself as both efficient and effective, which are impressive words for being lazy. So I also love EDM music, and I joined rowing at the Yarkon River, if is anyone familiar with that. And at Rookout, I take part of the SDK team. We are responsible for developing our debug SDK. And up until I joined Rookout, I was familiar with two ways of debugging applications. So up until I joined Rookout, I was familiar with two ways to debugging. First is the IDE's debugger, which is most convenient, and the other more easy way is to add a print statement. And with Rookout, they found out a better way to do debugging. Rookout allows you to debug any cloud-native application. We do that by placing a non-breaking breakpoint, which is just like your normal IDE breakpoint, but without stopping your application. We will see how we do that in just a few slides. So I've joined Rookout, and Python 3.10 came out, and my manager asked me, hey, do you want to add a support and support with our SDK for Python 3.10? I said, yeah, what does that mean? And he said, I have no idea, go figure it out. And so I did. I was reading through the documents of Python 3.10. And just before we jump on what's new with the latest Python, let's see how our debugger worked up until Python 3.10. Right. So this is a normal Python bytecode, Python code. We all know that. This example will go with us through this presentation. Just a simple code. I hope everyone understands that. And so we all know that Python is an interpreted language. What does that mean is basically it's not really interpreted language. We actually compile the language to Python bytecode. The Python bytecode is a low-level platform-independent representation of the code. This allows Python to run on various processors. So let's see what's a Python bytecode. Python bytecode is the low-level representation of the code, and we can access the Python bytecode using this. This is a Python library. I think the previous speaker introduced this library, and let's see how the code translates to exactly which instruction. So the first if translates to the 4 new instructions. We load A, we load the const bar, we do the comparison, and then we there is this pop jump if false. If the condition is false, we would pop to instruction 18, and if the condition is true, we will continue with the print statement, which is translated to these 4 instructions. And then we have the else if, which is translated to the instructions ranging from 18 to 24. So that's a Python bytecode. And let's see what happens when we add a breakpoint. Just before that, during the runtime, our Python, the C Python that is mostly common, it stores the Python bytecode inside bytecode object. It's a C struct, and we will get to this struct right in a few slides. So once we add a breakpoint, we will add a breakpoint to line number 3, just before the print. We want to see any information, any debug information that we could gather. And so once our Python SDK, it's not like how the Python debugger works. I'm talking about Rookout's Python SDK. We add 3 new instructions to the bytecode. Those are the 3 instructions ranging from instruction 8 to 12. Basically what we do is just call another function. This function collects all the debug information, all the local variables that we have on the stack, and some kind of stack trace and more debug information. We then call the function and pop the result from the stack. So this is the 3 new instructions that we add once we have a breakpoint. Please notice that on instruction 6, we have updated the jump instruction. It was 18, and now since we added 3 new instructions, we pushed down the rest of the instructions. So we have updated instruction 6, which is the pop jump if false, to instruction 24, which is the correct offset because we've added 3 new instructions. All right. So how did we know where to place the breakpoint? Because we've just seen a Python bytecode, and it's not really telling us what line is it referring to. Because when we want to debug, I've said that I want to add a breakpoint on line number 3. So Python, the bytecode object, actually holds metadata. There is one attribute that we look for, which is the core LNO tab. Basically, it's the line number table. It translates between the bytecode offset to the actual line numbers. So this way, debuggers and tracing tools can connect to the LNO tab and see and translate between bytecode offsets to line numbers. So let's quickly go through how does it look like. We have bytecode offset and we have the source code line numbers. We could store the table just like that. So bytecode of 0 would go to line number 2 and so on. But we can make a difference between each row to the next one. So if we did a difference, it would look like that. The first row does not have any difference. And each row is, we just do the difference between the previous row. So with the line numbers, each increment is by 1. But with the bytecode offsets, we have several increments. And eventually, you can access the line table by using the __ code. We can access. This is actual what the bar function that we have had. This is the line table. And so that was the situation until Python 3.9. Python 3.10 introduced a new line table. And that happened because this table had a few issues. The few issues that it had is several patches throughout Python versions. For example, in Python 3.6, they changed the bytecode sizes. So that broke backward compatibility. And the most major problem is that it didn't account for presence of bytecode without line number. They don't actually refer to bytecode that doesn't have a line number. This situation can happen because, for example, yield instructions and other situations where bytecode is being generated, but without line number actually to refer to. And another issue is that because of these two issues, tracing tools and debugger required a couple of workarounds. So it was tedious work, and they wanted to introduce a new line table. So they introduced PEP 626. PEP is a Python enhancement proposal where it talks about precise line numbers for debugging in other tools. And actually, it introduced just a new table. The table looks familiar. It's this time we're talking about bytecode offset ranges. So we have a start and end for each bytecode and the line that refers to it. Again, we do the difference between each row to the next. But this time we have a consideration for the no line number attribute. Basically, they did a magic number just to show that this bytecode does not belong to any line number. And eventually, the table would look like that. Please be advised that we have split all right. Each column here is a byte in long. The size of each column is byte. So we had to split the value of 300 to 2 different rows. That's why we see the first error and the second one. And there is a minus 128, which refers to no line number. That's the magic they decided to refer as no line number. Now, we all know that there is those kinds of errors, that there is error line number 42, but it doesn't exist. And Python 3.10 actually fixed that. We can see on line number 3 that there is a syntax error. So in Python 3.9, that would be the error. It says line number 4, but it is not. And Python 3.10 actually fixed that. There's a better syntax error, and it says the correct line number. Okay, so yeah, so that's enough background. And I was starting to look in PEP 626 to actually add the support for our debugger, and I found out that the PEP says that there is backward compatibility, which is that all the attributes would be deprecated in Python 3.10 and totally removed in Python 3.12. Unfortunately, that wasn't the case. When I was trying to compile the code, I got no member found. They actually removed this member from CPython, so I was not able to use the backward compatibility they promised. And so I went and read more information from PEP 626, and I found out that there is they introduced new functions to iterate through the table. Those three functions are those, and I was trying to link with those functions. I was trying to access these functions, and unfortunately, there was another surprise. The symbol is not found. They didn't export the symbol from the Python binary, which basically means it is a private symbol, and we can't use it outside of Python. So I had a couple solutions that I could think of, which is statically linked to libpython. This solution was not possible because our SDK raised from 100K to 4 megabytes in size. So that's not a possible solution. I asked the Python maintainers to export those functions. They actually still arguing about it in a GitHub issue. So I hope they actually do add a support for that. And the most easy thing that I could think of is copy-paste, which that's what I did, just to continue with the exploring what more surprises will come. So I did a copy-paste. I could iterate through the new line table, and it was time to actually run and use and see what happens. So this time we placed the breakpoint on the first if condition. And please notice that we call bar with the argument fufu. So the expected result would be just print fufu, and that's about that. So I went to our platform. I added a new breakpoint on the if condition, and this is what it looks like. Without going much into details, we can see up there that on line number 2 we have a breakpoint, and on the bottom right we can see that we have collected the debug information. This is the variable that we sent through the function, and well, that seemed to work. But once I've checked std out, I've found out that this is the actual print. So when I check the standard output, I see that a equals foo, and there is some weird print that says built-in function print. So that was not the expected result, and I was starting to figure it out why. And I said, okay, let's go back to this. Let's see what did I do to this function. So just a reminder, this is the this code. The first if translates to the 4 new instructions. Again, we can see that there is a pop jump if false, which is supposed to jump to instruction 18 if the condition is false. And then there is the else if, which refers to instructions 18 to 24. So we should have jumped to the else if, and let's see what happened when we actually added a breakpoint in Python 3.10. So with the breakpoint, I've added those 3 new instructions. Notice that they now at the top of the function because the breakpoint was on the first if. So we add the breakpoint just before the if occurs. So we have the call for our function for the collecting the information. And then we also needed to update the jump instructions. So we've updated instruction number 12 to jump to the new instruction, which is 230. And we can see that on line number 30, on instruction 30, it's actually the end of the else if. So we should have reached instruction 24, but we've reached instruction 30. And I was starting to figure out why. Why did that happen? Maybe I did the calculations wrong. Maybe I didn't figure the offset right. But I did not change that. I did not change the code that actually calculates the function and the offsets. So it was not supposed to happen. So after tedious work and some prints and lots of ways to try and figure out what's wrong, and also on certain breakpoints this condition happened and the others one it did not. I had found out that there is a diff between Python 3.10 and Python 3.9, and we can see that on instruction 12, when I have added a breakpoint, the offset was corrected successfully to instruction 24, but on Python 3.10, the offset was wrong, and we can see some weird syntax that says 230. So I wasn't really sure why is that, because this is the output from library this. So they actually translate the bytecode from bytes to this visual text. And after a long walk, I found another surprise in Python 3.10. I went to CPython's GitHub, and I found out that they've actually multiplied the values, the jump instructions, by 2. This was done because all the instructions in Python 3.10 are even, so there's no way to jump to an odd instruction. So why not multiply that by 2? But they did not document it anywhere, didn't write anything about it. I found out that other tools like PySpy and other tracing and debugging tools were surprised too by this multiplication. It makes sense because you can jump to an odd number, but at least document that. So when I found this this surprise, I fixed that, and yeah, I fixed on the 12th instruction. We can see that the jump was corrected to the correct instruction. Now we jump to instruction 24, which is the start of the else if condition, and this way we fix the problem. And so yeah, basically that were all the surprises, and everything had worked. I've seen the debug information. I've seen the standard output. It was correct, and yeah, everything had worked. So just to summarize and some key takeaways, please read the docs, but don't blindly trust them. They are not always right, and sometimes they are not even documented. Don't take debuggers for granted, because debuggers have bugs too, just like I did. Sometimes they are not well suited for the actual changes. And please challenge yourself to take a deep dive before you start exploring out new versions and new features, because I had no idea what changed, and I found out that this thing took me 2 weeks to accomplish. But yeah, took a deep dive into Python, started to open up issues for the Python team, and I hope they actually accept my offer for the change. All right, so thank you, and we're also hiring. And if you have some questions, I think we have time for that. Yes. Hi. Yeah.
So when they write in the release notes, there is backward compatibility.
Yeah.
And when they write, it's entirely backward compatible.
Yeah.
What do they mean?
They were supposed to have that attribute, the old line table, but the attribute was removed from the struct. So there was no backward compatibility. They were supposed to keep the attribute in the struct and up until Python 3.12, and they didn't.
Well, is skeptical when they write that it's completely backward compatible.
They will?
Yeah, like in the release notes. It was written completely backward compatible.
Yeah.
Then you started to work and discovered all those non-compatible issues.
Exactly. Yeah. Yeah, so they said they do backward compatible, but they didn't. They broke the promise. PEP is not always right. Thanks. Yeah.
How do you debug hookup?
How do we debug hookup? So for the Python SDK, it's really hard. I actually use Prince. I'm sorry. But for our own backend, we use our own SDK, so we can actually go to an recursion with that. Yeah. Yeah. Okay, thank you.